Hello friends, so from today onwards, I'm going to start one more playlist on the standard template libraries. This is a C++ topic and the template based libraries provided for the C++ is known as the standard template library. So in a standard template library, we will discuss about the various concepts related to the library like containers, the iterators and the algorithms. These are the three basic components of standard template library. But before starting into the standard template library, I think we must need to know few of the basic concepts which will be really helpful for you to become a good programmer of a standard template library. In fact, I should say a good user of a standard template library. All right. So before I go to the standard template library, I'm going to discuss today about the functors. And not only in this video, in fact, for 4 or 5 more videos, I will be discussing about the basic concepts, right, which are related to the C++ templatized library. Okay, so today what we are going to discuss, today we are going to discuss about the functors, what are the functors, and then we will discuss what are the predicates, what are the unary predicates, what are the binary predicates, and how we can use the functors and unary predicates with vector. Vector is a standard template library object. It has been provided by the standard template library. It's a templatized class. We will discuss deeply in the vectors, for the vectors in the coming videos when I will discuss actually about the standard template libraries, but I will use it because its use is very simple, and I will give you a feel like how these predicates, how these functors, and how these unary binary predicates, how they are useful while you are performing certain operations on a vector, right? On or you can say for with any container, right? So vector is the simplest one, so I will use this one. This is simply like just like a just like an array, right? So that is why I have taken vector, and using it using the vectors is very simple. So I will use this vector to show you that how these functors, predicates, all these algorithms are used with the standard template library containers, right? So you will find it very useful, and you will find it you will enjoy it learning it. So let's start with this one. So today I'm going to first discuss about the functors. What are the functors? Functors are nothing but the functions, objects as functions, objects of a class as functions, which means that whenever we will create an object of a class, that object of the class can be used as a function, right? How we can do that? Let's see. Let's write a function, a class, test functor, and then just write a public function. And when you have to create a functor, which means you are creating a class whose object will work as a function, right? So for that, what you need to do, you need to overload an operator. And what is that operator? This operator. And then you need to provide the arguments like int a, int b, right? And this functor is going to return an integer, right? Int a, int b, right? So this is the syntax, return type, and then you need to overload this operator. And for this operator, you need to provide the arguments like int a, int b. These are the two arguments that this functor will take, right? This operator will take. So return a plus b. Basically, this operator is returning the sum of the two arguments that has been passed to it, that have been passed to this particular operator, right? So now we will see that how we can use it. So we are going to put something like test functor. We are going to create an object tf, and then we are going to use this object as the function, right? So tf, and then you need to give two arguments, 23, 40, 34, right? So now what will happen? It will return the sum of 23 and 34 into k. So if you print the k, the value of k, what will happen? It should print 57, right? So let's see when it runs, then what happens? Okay, 57 comes here. right? So here you can see that I have created an object, but I have used this object just like a function, which takes some arguments and returns some values, right? So if you have to create a functor, which means a class whose objects can work as a function, then in that case, you need to overload this operator, all right? So if you want that this function should not return any value, then in that case, you can just print inside this, or you can just perform any kind of operation in this. So it's like a plus b, I'm going to print here. I'm not going to do anything here. It's not returning anything. I'm just calling it, and I just need to remove this. And let's see what happens now. So this will call this operator and will act like a function. So again, 57 was printed, right? So now I hope you are understanding that what is the meaning of a functor and how you can create a functor, and what you need to do if you want to create a functor out of your class, which means if you want that object of any class should work as a functor, then in that case you need to overload this particular operator and you can provide any number of arguments here, or you can say that if you don't want to provide any argument, then you can do that also, right? You can just remove the arguments, right? So you just need to remember that you need to overload this operator. Okay, so that was about the functors. Now let's see what is the other topic. What are the unary predicates? Okay, so first let's understand about the predicates. Predicates are something which returns true or false, right? Suppose I write a function int is odd or is even. If I'm writing a function which takes only one argument and returns whether it's a even number or odd number, right? It returns true or false. Okay, so when a function takes only one argument and returns true or false. I repeat, when a function or a functor returns a Boolean value and takes only one argument, then in that case, such kind of functions, such kind of functors, or you can say such kind of lambda expressions as well, which you might be studying about the lambdas in the coming videos. So any such thing which is returning a Boolean value and taking one argument is known as a unary predicate, right? And in broad terms, if we talk about the predicates, then predicates are something which returns true or false. And unary predicates, they are something which returns true or false and takes only one argument. So this is all about the definition of the unary predicate or the predicates. Okay, so first we will see about the predicates, and we will create the predicate using a functor, right? Unary predicate. Okay, so this is the unary predicate, test predicate, and here I'm going to give a Boolean value, and here what I'm going to do, it's returning like if the number is odd number, even number or not, right? So return a percentile 2 is equal to 0. So if this holds true, then my number is an even number, otherwise my number is an odd number. Okay, so let's see, test functor t, and then here I need to pass just tf23, and here you need to put bool b is equal to tf, and now need to print it, cout endl b. So what it should print? It should print 0 because 23 is not a even number, not an even number, right? So it will return false and it will print 0. Okay, so it is returning 0. So if I write here 23, 24, then it will return 1. Okay, so this is all about the unary predicate. So if you are able to understand the functors, then you will be able to understand everything, whether it's test predicate, whether it's a unary predicate or binary predicate or anything, right? So to make it template based, you can write like this: template class t, and here you can do something like this: t a, and then return a percentile 2 is equal to 0, right? So here what I will do, if I need to do this, then I need to write this. I need to provide the type on which I'm going to work, right? So if you are writing a writing a unary predicate which is templatized, then in that case you need to use it in this way, right? So you need to provide the name of the class, and then inside the angular brackets you need to pass the type of the data type of the object on which you are going to work. So here I have written TF, and then I'm passing 24, and now it will print 1 because 24 is a binary an even number, right? So 24 is an even number, and that's why it will print 1. Same thing holds true for the functors. You can also write the functors using the template based classes, using the templatized versions. So you can do that. I leave it up to you to do that. Okay. So now let's see what about the binary predicates. Okay. So TA, TB. Rather, I should give TA, T reference of A and reference of B. And here I just want that it should return true only if A is greater than B, right? So I'm just going to change the name test greater than. Okay, so I'm giving the name of the um, predicate, binary predicate as test greater than, and which is in fact a functor, which is a binary functor. You can say a binary predicate. So that I'm going to do. So if my first number is greater than the second number, then only this will return true. So here what I can do, 24 and 13, and here what I can do, TF test predicate is not there, so test greater than is here, right, like this. And now let's see what happens. Here you can give the name GF, here you can give the name GF. Okay, so why it is giving the problem GF, let's see. Okay, so bool is cannot convert one from int to T reference of A. Okay. So I need to pass integer A since I have provided a reference here. That is why it is giving the problem. So just put it like this way and let's see what happens. Now it should work. Okay, so it has returned 1 because my first number, which is 24, is greater than 13. So this is how the binary predicates are working. Okay, let's move ahead and let's see some example uses of the functors and the unary predicates with the vector, which was our third topic. The fourth one I have covered, use of binary predicate, what is unary predicate, and the first one I also covered. So the only thing remain is use of functors and unary predicates with vectors. Okay, so if you have to use the vectors, you need to include this hash include vector. So I'm just going to use vectors here. I'm just going to remove everything else. And first I will write a templatized version of a unary predicate. Sorry, a function, a functor. So what I'm going to do, vector, first I'm going to use vector int, which will store the int v. And you just need to remember this function name, push back, and 12 v dot push back 13, and I just need to copy paste it for more values, 14, 15 and 14. So this is the way it is working. So I just want to count those numbers which are divisible by 2, which means which are the even numbers. So what I need to do, I'm just going to write a test even. I'm just going to write a test even number class, which will act like a unary predicate. So what I'm going to do, public, and I'm going to just return bool operator, and then I need to provide only one argument. Let's do that this way, TA, and on the top I just need to give template class T. Okay, and then I just need to return A percentile 2. Okay, so this is the way it will return. If your number is divisible by 2, then in that case it will be an even number, otherwise it will be an odd number. So the standard template library provides one algorithm for using the algorithm, you need to use this, you need to include this algorithm header, right? So I'm just going to include this algorithm header here. So what I'm going to do here, in this algorithm header, there is a function count underscore if, right? Count if is a function which is used here. So what I will do, it expects three things. First thing is the beginning of the vector, which means the container, and the beginning of the container can be marked by v dot begin. V dot begin basically marks the beginning of the vector. Basically, it returns an iterator which is pointing to the beginning of the vector, from where I have started putting my data into the vector. And then the second argument is v dot end, and then I need to give the name of the function, and here I'm going to give that name, and I'm going to provide the int because it's a templatized version, and here I'm just not going to provide anything. Why I don't have to provide anything? I don't need to give anything here. Okay, I just need to provide this and don't need to give any argument here. So what will happen that it will, this count if will iterate through the vector. It will start from here 12, 13, 14, 15, and every number it will pass into this test even number, and then it will just check if a particular number is even number or not. If it is even number, then if this function, basically if this functor, or you can say the unary predicate, if this unary predicate returns true, then inside the countif what will happen, inside the countif the count of the numbers that it has to count based on this predicate will keep incrementing, right? And it will count all those elements which are true as per this predicate, right? So there are only two elements which are true as per this predicate, so it will give me a value 2. So int k is equal to countif, and if I print it endl k, it will return me 2. So just do this. So you can see that it has returned 2. Okay. So why it is returning true? Because inside the countif, what happens that it checks every element in this range from beginning to end. From beginning to end in this range, it checks for every element whether a particular element is true as per this particular predicate or not. And this predicate says that I will return only true if it is an even number, if it is an even number. So if it returns an even number, then countif will keep incrementing the number, keep incrementing a variable which is counting the numbers which holds true for this particular predicate. And ultimately, when all the elements have been iterated, it will just return that value. So this is how it works, countif. So this is the standard function. But what if someone says to you that you need to write your own countif, right? So let's see that one as well. So just add one more topic for today that I'm just going to cover it as well. Use, or you can say write your own countif function. Countif algorithm, rather I should say. Okay, so I'm just going to remove this algorithm so that I can use my own countif. But in anyways, I'm just going to name it something else, underscore countif. So what I will do here, it's like int. So first I just need to write like, I need to write it like something like templatized. Although you can write it without any template, but it's better to be in sync with the protocols. Like if we are learning the standard template library, so we should, we should keep motivated to use the templates in everything. Okay, so let's do one thing. Template class tree and bool, not bool, it's int, and then write is my function, no, class tree, and I'm just going to write underscore count underscore if, and then t and then it is taking two arguments. So it is like class underscore iter as well. So first argument is iter beginning, second argument is iter end, and the third argument is the template function. So class underscore predicate, right? So it is a predicate. So underscore predicate pred. Okay, so here I'm going to give a name, count is equal to 0, and then what I'm going to do, while beg is not equal to end, what I will do, I will simply pass bool b is equal to pred, and two arguments, one argument it will take, and that argument will be asterisk of beg beginning, which is the value. Basically beg is the iterator, but if you want to see the value what is stored at the iterator end, that will be indicated by this asterisk beg. Okay, so let's move ahead. If b, which means if it is returning true, then in that case count plus plus. Okay, so what will happen, like it will keep iterating and then beg plus plus, right, which means that I'm iterating ahead from the current position. So what I'm going to do, I'm just iterating from the beginning to the end and passing each element to the predicate and just checking if it is true or not. If it is true, then I'm just incrementing count, and at the end I'm just returning count. Okay, so rather than countif, I'm just going to use my own version of countif. Okay, so everything else is same. We are passing the iterator, one iterator, this is iterator, and this is my predicate, right? So here the same way I have written it, beginning, end, iterators, and the predicate, right? So now let's see if my predicate is working or not, my countif is working or not. Okay, so it is giving me 2, so it's working perfectly fine. So now you understood like how you can write your own algorithms as well, right? So you can understand that how useful these concepts are when you will be working with the containers, because using the containers, knowing about them is not just enough in STLs. You must be able to wisely use them. You must be able to you can say like you should be able to very proactively innovative to use these kind of concepts which are already there, right? So just knowing about the vectors, just knowing about the list, just knowing about the queues, dequeues, and all that, that will not work. If you are going to work with the STLs, standard template libraries, then you must be aware about these things. Okay, so we will meet in the next video. Till then, have a nice day and bye.